The most dangerous animal in the prehistoric world did not appear to be dangerous at all. It had no claws worth mentioning, dull teeth, no armor, and a top speed a nervous antelope could beat without much effort. A lion could kill it in seconds, a bear could break it in half, a single annoyed mammoth could remove it from the landscape without breaking stride. And yet, across tens of thousands of years and every inhabited continent, animals learned to fear this creature more than almost anything else that walked, swam, or flew. Not because of its body, because of what its body was rarely alone in carrying, planning, and remembering. Let's take this apart properly, because the honest answer is more interesting and more scientifically careful than the simple version usually told. Start with what fear actually is, biologically, because the word gets used loosely, and it matters here. Fear is not a mystical recognition of danger. It's a set of measurable responses shaped by evolution, individual experience, and social learning, triggered by a cue, a smell, a shape, a sound, a location that has previously been associated with harm. Heart rate spikes, attention narrows, an animal freezes, flees, groups together, or turns to fight. Different species lean on different combinations of these responses, and none of them are perfectly tuned. Too little caution gets an animal killed. Too much caution wastes energy and mating opportunities, running from things that were never actually a threat. Natural selection doesn't produce maximum terror. It produces useful suspicion, calibrated as precisely as the environment allows. This is where ancient humans created a genuinely strange problem for the animals around them, because most predators advertise exactly what they are. A big cat has forward-facing eyes, heavy shoulders, and the low, coiled movement of an ambush hunter. A wolf arrives with teeth, speed, and several relatives who share its interest in the outcome. An eagle drops from above with the subtlety of a falling rock. These are recognizable templates, and prey species can evolve dedicated responses to them over generations. Humans didn't fit cleanly into any of it. Standing upright made us narrow and unfamiliar from the front. Our hands carried different objects on different days. We could approach slowly and pass by without attacking, or approach slowly and not pass by at all. Sometimes a human left food behind. Sometimes a human returned hours later with 20 more humans and a plan. We were, ecologically speaking, extremely difficult to classify, and that ambiguity mattered most during the very first encounters between a human population and an animal population that had never met one before. Ecologists have a specific term for what happens next. It's called prey naivety, and it describes exactly this situation. An animal that fails to recognize a new predator, recognizes it too slowly, or reaches for a defense that worked perfectly well against an old threat and does nothing against the new one. Island species were especially vulnerable to this because many of them evolved for millions of years with few or no large ground predators at all. A ground-nesting bird might be flawlessly adapted to avoid an eagle diving from the sky while having no useful response whatsoever to a primate simply walking directly toward its nest on two legs. The bird wasn't foolish. Its instincts were accurate right up until the world changed underneath it. As ancient humans expanded into Australia, into islands scattered across the Pacific, into the Americas, they repeatedly walked into ecosystems shaped by animal lineages that had never once had to plan around something like us. The exact causes and timing of the resulting prehistoric extinctions remain genuinely debated among researchers, and vary considerably by region. Climate change mattered, shifting habitats mattered, and small and fragile populations mattered on their own. But first contact in these situations could be catastrophic for a specific, cold reason. Fear had not yet been trained into the population, and an animal that let a hunter get 10 meters closer wasn't just giving up 10 meters. It was giving up the time it needed to escape, choose better ground, protect its young, and warn the rest of the herd. The individual who survived the encounter might learn something valuable from it. The individual who didn't survive taught nobody anything at all. By the time this dynamic was playing out across the Pleistocene world, humans had already been dangerous for a very long time, long before metal, cities, or writing existed. At a site called Schöningen in Germany, archaeologists recovered a set of wooden spears, throwing sticks, and other carefully worked wooden tools from sediment layers roughly 300,000 years old. Building them required selecting the right wood, shaping it precisely, and understanding balance well enough to produce a functional hunting weapon rather than just a pointed stick. And it's worth noting that wood seldom survives that long. The archaeological record is heavily biased toward stone, which fossilizes beautifully, while the wooden shafts, cordage, carrying frames, and trap components that made up most of the actual ancient toolkit have simply rotted away and vanished from the record almost everywhere else. The animals encountering ancient humans were very likely facing a technological toolkit considerably richer than what survives in a museum case today. The spear did something specific and genuinely unusual to the normal logic of predation, because for almost every predator on Earth, danger increases as distance decreases. That gives prey a simple, reliable rule to live by. Watch the threat, hold your distance, and run once the gap closes past a certain point. A thrown weapon breaks that rule completely. A human could stay outside, biting, kicking, or goring range entirely while still transferring lethal force across the gap between them. A zebra can comfortably outrun a person over open ground. It cannot outrun a sharpened point that's already crossing the last 20 meters toward it. And once a group, not just one person, could reliably injure an animal from beyond its own physical reach, raw strength and speed stopped being the protection they'd always been. Groups mattered here in a way that goes beyond simple numbers. Wolves hunt in packs. Lions cooperate. Orcas pass hunting techniques down across generations. Humans didn't invent teamwork. What we did was make it unusually flexible. One person could read tracks in the dirt. Another could judge wind direction. Someone waited quietly near the water. Someone else remembered exactly where a herd had crossed during last year's dry season. A child could simply watch and absorb the process for years before ever being strong enough to fully take part. The hunt often existed as a plan inside several different minds before it ever happened on the ground, which made humans dangerous in a way a solitary ambush predator simply wasn't. Escaping the hunter you could see didn't guarantee escaping the plan you couldn't. An animal could run in exactly the direction its instincts told it to run and discover that the humans had already anticipated that exact option and were waiting there. Fire deserves its own place in this story because animals weren't only afraid of humans directly. Many were afraid of something humans had learned to carry with them. Wildfire itself is ancient, and animals had already inherited responses to smoke, heat, and the sound of burning vegetation. Some flee immediately, some retreat underground, some are drawn toward previously burned ground once it's safe again. Ancient humans learned to fold this pre-existing fear into a deliberate strategy. Controlled fire could clear dense vegetation, improve visibility, encourage fresh plant growth that drew grazing animals back later, and actively drive game in a chosen direction. Exactly how early and how extensively deliberate landscape burning was used varies by region, and archaeologists can't confidently assign every ancient layer of charcoal to human intention rather than a natural blaze. But controlled fire, once it existed, multiplied human influence enormously. A lion occupies one specific location at a time. Smoke can occupy an entire horizon. An animal never needed to actually see a hunter to be moved, herded, and controlled by the hunt itself. Then there's persistence. A genuinely strange human specialty. We are not fast animals. But we are, under the right heat conditions, exceptional endurance movers. A combination of upright walking, sweating across nearly the entire body, comparatively little fur, and the ability to carry water that lets humans keep moving in conditions that overheat and disable many other mammals. Persistence hunting, tracking an animal and repeatedly pursuing it until heat exhaustion strips away its ability to keep fleeing, has been documented ethnographically in modern hunter-gatherer groups and remains a serious, actively discussed hypothesis in research on human endurance evolution, though it should not be treated as the single universal hunting method of prehistory. Plenty of ancient hunts relied on ambush, thrown weapons, or traps instead, but the possibility reveals something genuinely unusual about human predators specifically. For most animals, running away quickly ends an encounter because a burst of acceleration is expensive and overheating is dangerous, so predators tend to give up the chase fast, and prey evolved around that exact bargain. Survive the initial burst, put some distance between you and the threat, and the crisis is usually over. A human tracker could simply arrive again later. The prey sprinted, the human read the broken grass and the disturbed soil left behind. The prey hid. The human noticed the direction, the timing, the small signs an animal leaves without ever knowing it's leaving them. Movement itself became information a predator could follow long after the original chase had technically ended. None of this is speculation about ancient feelings we can't access. We have a genuinely striking modern comparison. In 2023, conservation biologist Liana Zanet and colleagues at Western University published a study in the journal Current Biology examining exactly this question in South Africa's Greater Kruger National Park, home to one of the largest remaining lion populations left on the continent. Using camera and speaker rigs set up at waterholes, the team played recordings of ordinary human conversation in 4 local languages, alongside recordings of barking dogs, gunshots, and lion growls and snarls, then measured how 19 different mammal species reacted. The results were stark. Roughly 95% of the species tested fled more often and fled faster from the sound of calm human conversation than from the sound of lions. Animals were about twice as likely to abandon a waterhole entirely after hearing people talking than after hearing lions. And when they did run, they ran roughly 40% faster from human voices than from the continent's most feared big cat. No visible person, no weapon, no vehicle, just conversational speech, and it outperformed the actual sound of an apex predator as a trigger for flight. Zanette and her colleagues described this as consistent with humans functioning as what ecologists now call a superpredator, a term formalized in a separate, influential 2015 study in Science led by ecologist Chris Darumont, which found that human hunters and fishers routinely kill adult prey, the individuals responsible for a population's future reproduction, at rates up to 14 times higher than other predators manage, targeting healthy, mature animals in a way most natural predators, which tend to focus on the young, old, sick, or isolated, generally don't. It would be dishonest, though, to present this as a one-sided story of total domination, because for most of our evolutionary history, humans were prey as well as predators. Cave sites preserve periods when large carnivores clearly occupied shelters before or after humans did, and some ancient bones carry direct physical evidence that big predators treated early hominins as food, not as a threat to avoid. A lone human at night could absolutely become a meal. What changed the calculation wasn't human strength, it was what happened after. Killing one person could bring several armed, furious adults back to that exact location. Humans could track a predator to its den, remove access to a kill, burn the surrounding cover, and remember precisely where all of it happened months later. Most predators respond only to the animal directly in front of them. Humans could respond to what happened yesterday, which made us a genuinely strange, delayed kind of threat that a purely instinctive competitor had no good way to evaluate by size alone. This is also why the word terrified needs a little scientific restraint here. We cannot know the private inner experience of a mammoth watching hunters approach across open ground. Archaeology preserves weapons, kill sites, bones, footprints, and population changes. It does not preserve an opinion. What we can measure is behavior, avoidance, heightened vigilance, changed feeding patterns, changed activity timing, tighter defensive grouping, physical stress responses, and when those signals are consistently strong, calling the response fear is a reasonable, ordinary use of the word, even if the safer, more precise scientific phrasing is that many animal populations learn to treat humans as an unusually serious predation risk. And that risk became something ecologists call a landscape of fear. The way a population's perceived danger reshapes where, when, and how animals actually live, not just whether they're killed. Fear alone can suppress feeding, even when nothing is caught that day. It can push animals away from good water sources, rich feeding grounds, or preferred nesting sites. Herd animals watch each other constantly. An alarm spreads through posture, sound, and sudden movement long before any individual has to personally test whether the danger is real. A young animal doesn't need to survive an actual spear wound itself if its mother has already learned to move away the instant smoke or human voices appear nearby. But this kind of social learning cuts in both directions. When the most experienced individuals in a group are killed, the survivors can lose the very knowledge that made them cautious in the first place. The safe routes, the dangerous crossings, the specific memory of what human danger looks like in that particular valley. Hunting doesn't just reduce numbers, it can quietly erase the map. Fear also produced one of the strangest reversals in this entire story, because not every animal responded by running further away. Some moved closer instead. Wolves that tolerated the presence of human camps could scavenge scraps and carcasses while avoiding more aggressive, less tolerant rivals. Certain wild cats were drawn toward the rodent populations that clustered around early human settlements. Other species gradually learned that proximity to humans meant fewer competing predators nearby, a more reliable food source, or genuine shelter. For these specific animals, reduced fear opened up an entirely new ecological niche, and what followed, eventually, was domestication. Not the total defeat of every animal that stopped running from us, but in several documented cases, proximity became a deliberate strategy in its own right. The same human shape that could mean sudden death to one species could mean grain, shelter, protection from larger predators, and an entirely different evolutionary future to another. So why were animals terrified of ancient humans? Not because they instinctively recognized us as some kind of ultimate apex predator the moment we appeared. There was no single afternoon when every species on Earth got the memo. Plenty of animals badly underestimated early humans at first contact. Some attacked us outright. Some simply ignored us entirely, at least until the lesson became expensive. What actually built the fear, over countless individual generations, was accumulated experience, social learning passed between individuals, and ordinary natural selection quietly favoring whichever animals happened to be more cautious around this specific, strange, upright creature. They fled sooner. They shifted their routes. They changed which hours of the day felt safe to be out in the open. What made humans so frightening was never really one single trait. It was the combination, arriving all at once, in a body that didn't look dangerous at all. We could wound from a distance that most predators couldn't match. We could coordinate with allies, but the prey animal couldn't even see yet. We could pick up a trail again long after the actual chase had technically ended. We used fire and terrain as tools instead of obstacles. We built traps that stayed lethal long after we'd already walked away. And when a technique worked, we didn't just use it once. We remembered it, refined it, and taught it to somebody else. A lion was frightening because it was a lion, a single, physically formidable animal doing exactly what its body and instincts had always done. A human was frightening for an entirely different reason. Because standing in front of a prey animal wasn't really just one soft, slow, unarmored body. It was quite possibly carrying the accumulated knowledge of 100 hunts that the animal itself had never even witnessed. The animal was only ever looking at one creature. What it was actually facing was a culture, and by the time enough of a species finally learned to fear that properly, a great many of them had already, quietly, disappeared.